Welcome to today's Explainer. We've got something absolutely fascinating to unpack today. We are going to connect the deep, largely unseen physical realities of our changing oceans with the highly speculative models of global climate policy. Essentially, we're bridging the gap between hard ocean physics and the high-stakes world of international climate targets. Okay, let's dive right in by looking at our starting point: human-driven industrial emissions. We're putting unprecedented pressure on Earth's interconnected systems. Now, we all know we've been pumping greenhouse gases into the air for decades, but you know what? The atmosphere is really only half the story. The true engine of our climate system, the massive entity absorbing the vast majority of all this excess heat, is our ocean. To wrap our heads around all of this, here's our roadmap for today. First, the hidden ocean crisis. Second, the slowing conveyor belt. Third, the danger of overshoot. Fourth, the techno-fix illusion. And finally, we'll wrap up with the urgent path forward. Let's kick things off with part one, the hidden ocean crisis beneath the surface. So the very first concept we really need to nail down is ocean stratification. Simply put, the ocean isn't just one giant, uniformly mixed bathtub. It actually forms distinct layers dictated entirely by temperature and salinity. Warm, fresh water is less dense, so it naturally sits right on top of colder, saltier, denser water. It's exactly like oil and water in a salad dressing. They just want to separate. And you can see that stark division beautifully illustrated right here. We've got this warm, fresh upper ocean that interacts with weather and sunlight, completely separated from the cold, dense, deep ocean. The boundary between them is called the pycnocline. Now, because human activity is actively warming the surface and melting freshwater ice caps, this top layer is getting even warmer and even fresher. That means the density gap between the top and bottom layers is getting way more extreme. Now, check out this number, 0.8%. According to extensive ocean physics research, stratification in the global upper 2,000 meters has gone up by about 0.8% every single decade since the 1960s. That might sound like a tiny percentage, right? But on a planetary scale, that is a massive structural shift. The ocean is literally locking itself down. What's really wild about this is how that barrier layer limits vertical mixing, which is basically how the ocean breathes. When that barrier gets stronger, it completely blocks the crucial exchange of heat, carbon, and oxygen. This ends up suffocating marine habitats and trapping way more of our emissions right up in the atmosphere. So, as the ocean's layers become more rigid, it brings us right to section 2, the slowing conveyor belt, the AMOC. Let's talk about the AMOC, the Atlantic Meridional Overturning Circulation. Think of it as a gigantic global heat conveyor belt. Here's how the loop works. First, it transports warm, salty water all the way north from the tropics. Second, it releases that heat into the air, which actually keeps Europe's climate mild. Third, once it cools down, the water gets super dense and sinks. And fourth, it flows all the way back south through the deep ocean. But because melting polar ice caps are dumping so much fresh, less dense water into the North Atlantic, the water just isn't getting dense enough to sink anymore. The engine is losing its power. And that leads us to a pretty staggering projection: 51%. A brand new study using advanced statistical techniques to correct biases in older models projects that the AMOC could weaken by a massive 51% by the year 2100. That is roughly 60% higher than what standard climate models used to predict. The real-world consequences of this, they are incredibly intense. A weakened AMOC could completely shift tropical rain belts, which would devastate monsoons in West Africa and South Asia. It threatens Europe with extreme, brutal winters, and it accelerates sea level rise right along the US Northeast coast. And the scariest part, if it weakens too much, the AMOC crosses an irreversible tipping point where it just shuts off entirely. These breaking physical systems naturally push us dangerously close to global boundaries. Section 3, the danger of overshoot, crossing the line. Okay, so in climate policy circles, you're gonna hear this buzzword, overshoot. Let's de-jargonize that for a second. It basically means blowing past the 1.5 degrees Celsius warming limit set by the Paris Agreement, even if it's just temporarily, with the hopeful idea that we can somehow bring temperatures back down later. But the science unequivocally warns us, we can't just turn the global thermostat back down once we cross that line. The Intergovernmental Panel on Climate Change is brutally clear about the chain reaction and overshoot causes. Every fraction of a degree matters. Exceeding 1.5 degrees triggers self-reinforcing tipping points. Think permafrost thawing or entire forest ecosystems collapsing. You literally cannot unthaw permafrost, right? You can't unextinct a species. These harms are strictly irreversible. And gambling on bringing temperatures down later totally ignores the catastrophic, permanent damage done while we're over the limit.
So, how are policymakers handling this? Let's move to Section 4, the techno-fix solution, modeling a false reality.
If you read through global climate mitigation plans, you're immediately hit with an absolute alphabet soup of speculative tech. You've got CDR, or carbon dioxide removal, there's CCS, carbon capture and storage, BCCS, bioenergy with CCS, and SRM, solar radiation modification. A huge number of the models that governments use to plan their policies actually assume we're going to deploy these technologies on a massive scale in the future, which conveniently allows us to keep using fossil fuels today.
But as the IPCC itself outlines, relying on this stuff is incredibly perilous. Take solar radiation modification, which literally involves trying to reflect sunlight away from the Earth. I want to read this stark warning neutrally, straight from the IPCC. Quote, SRM introduces a mask to the climate change problem. Rather than attempting to address the root cause, its risks and potential for risk reduction for marine and terrestrial ecosystems and biodiversity remain largely unknown. End quote. It's basically a giant mask, and if we put it up and never had to take it down, we'd risk something called termination shock, triggering rapid, violent warming.
So we have this huge disconnect. On one side, you have these sterile, highly optimistic models that just assume we'll suck vast amounts of carbon out of the sky by 2100. But on the other side, we have harsh physical reality. Carbon dioxide removal is completely unproven at scale. Deploying it would take unfathomable amounts of land, water, and energy, potentially rivaling the entire globe's electricity production. And mathematically speaking, these technologies simply cannot stop the critical overshoot happening right now.
We've seen the physics, and we've seen the risks of these speculative models. Let's get down to the core truth in Section 5, the urgent path forward, the real solution. If we don't rely on fantasy carbon capture, this is the hard mathematical reality of what has to happen by 2050 to stay under 1.5 degrees. Coal use has to drop by 100%, oil by 60%, gas by 70%. This represents a massive, immediate reduction across the board. The analyses are crystal clear. Pathways that rely on large-scale carbon removal later are inherently pathways that accept dangerous overshoot today. And the underlying science from the IPCC reinforces this absolutely, with no caveats. Quote, the achievement of long-term temperature goals in line with the Paris Agreement requires the rapid penetration of renewable energy and a timely phasing out of fossil fuels. There is simply no magic substitute for the rapid, immediate phase-out of emissions alongside massively scaling up energy efficiency right now. So this brings our explainer full circle. The models might offer us this really comfortable, easy storyline leading up to 2100, but the hard data tells us that what we do right now in this exact coming decade determines our entire trajectory. The oceans are already stratifying. The AMOC is already slowing down. Physics does not wait for policy. The science leaves us to consider the immense stakes of our current choices. Will global policy actually phase out fossil fuels today? Or are we just going to keep gambling the Earth's physical systems on a plan B that quite literally does not exist? Thanks so much for joining me on this explainer. Keep questioning the models, and as always, keep looking beneath the surface.